Today we are going to cover section 7.3, matrices and systems of equations. Don't forget to leave a space for your essential question, and we can do that at the very end once you kind of get an idea of what we cover in the lesson. Copy example number 1, and then once you're ready we can start. Go and pause it. Excellent. So at this point you should have it copied down. We are looking at matrices, so we are going to go from a system of equations. We are going to rewrite it as a matrix, but as what we call an augmented matrix. Since we are going to include the equal sign, that's going to make it into an augmented. So first we are going to place a matrix symbol, so just a bracket, and I'm leaving 3 spaces because we have 3 different equations. And I'm just going to write down the coefficient. So therefore the coefficient for the first x is 1, for the y is 1, for the z is 1, and we have a 2. And now I can close it. I want to do the same thing for the second equation. We have a 2. There's no y, so it'll be a 0, 3, and negative 1. And for the last one, we have a negative 1, 2, negative 1, and 4. And now, instead of my equal sign, I'm going to place a line. That will be my equals. And we're going to be able to use matrices throughout this chapter to be able to solve systems of equations. And then your calculators have that option where we can actually use the matrix, type it into the calculator, and it'll give us the solutions. But we'll be doing that next time. Go ahead, you should have a cutout. Go ahead and glue it and copy example number 2. And we can start once you're ready. Go ahead and pause it, and once you're ready, we can continue. Excellent. So in this case, elementary row operations. We can actually perform operations on rows, and you'll produce a new matrix that represents the system with the same solution set. So therefore, as we do several operations, our solution set will be the same. Same thing that whenever you multiply an equation by 2 on both sides, it'll be the same concept. The first 2 rows of a matrix can be interchanged, and that'll be on example 2a. So we have a matrix. This is called a 3 by 3, so we have 3 rows and 3 columns. So therefore this is a 3 by 3. We do the rows first and the columns next. So I'm going to switch row 3 and row 2. Therefore row 1 will stay the same. So row 1 will be 2, 1, and 4. Notice that when I write them down, I always leave a space in between. My row 3 will become my row 2. So there'll be 0, 1, and 2. And my row 2 will become my row 3. Now we need to be able to annotate on the left hand side that we switch those 2 rows. So therefore I'm going to place a arrow to indicate that they got rotated or they got switched. On the second one, we are going to multiply row 2 by 1/2. The elements in any row may be multiplied by a non-zero number. So that'll be on letter B. That means that we multiply the second row by 1/2, which means that the first row will stay the same. And the third row will stay exactly the same. This is the only one that we are changing. So therefore, we want to be able to place the notation on the left, 1/2 row 2. And now we're going to take half of row 2, so that'll be 2. Half of 0 is 0. Half of 6 is 3. And for the last one, add a multiple of a row to another row. So we can add a multiple. In this case, we're going to multiply by -2. Row 2, we're going to multiply by -2, and I always place the -2 right next to it, so it kind of helps me make less mistakes. And I'm going to add it to row 1, which means that row 1 and 2, row 2 will stay the same because we are only going to change row 1. Row 3 will stay the same. The only one that's going to get changed is row 1. So therefore, we're going to place that notation on row 1. -2, row 2. So multiply row 2 by -2, and we're going to add it to row 1. This is row 1, that should be on the first row. So let's see. -2 times 4 is -8. Added to row 1 gives me a -6. So -2 times 4 is -8, plus 2, -8. -2 times 0 is 0, plus 1 is 1. -2 times 6 is -12, plus 4 will give me a -8. So this matrix and this matrix will have the same solution set. It doesn't matter if we make those row operations. Now, you guys at this point should have a cutout, so go and glue your cutout, and now also copy example number 3. And then we can talk about the cutout and work through example number 3. Go and pause it. At this point, you should have it done. Ready? So let's go through the cutout. A matrix is in row echelon form if every row has a leading 1. So therefore, your first row, each row, the leading number should be 1. The leading number should be 1. Notice that in this case, there's no 1, so this one's still fine. It's considered row echelon form. And on the last one, each row starts with a 1. And every number below is a 0. So every number below the 1 has to be a 0, and it is. So notice that even though that's a 5, because we have a 1 before that, that's also considered a row echelon form. We usually say that there's a triangle on the lower side of zeros. And we're going to use the following steps. Step 1, 2, 3, 4, 5. Now let's start with problem number 1. On problem number 1, the first thing that I want to do, I want to be able to rewrite it in augmented matrix. So I want to be able to rewrite it as an augmented matrix. So I want to leave some space on the left hand side because I'm going to be writing my notation on the left. So we have 1, -2, 3, 9, -1, 3, 0. There's no z, and -4, 2, -5, 5, and 17. And now, according to my cutout, my first step is to make this first number 1, which is already 1. So therefore, my first step is done. My first step is done. Then the second step, use the 1 in the first column to get zeros below it. So I'm going to use this 1 here to make that a 0 and that a 0. So let's make this second row a 0. So therefore, we're going to use the row operation. So what can I do to make that 0? I can add row 1 to row 2. So which means that row 1 will stay the same. The only thing that we're going to change is row 2. So row 2 is going to get changed. And I want this to be a 0. So therefore, we're going to add row 1. We're going to add it to row 2. Notice that this is row 2. That should be on the row 2. The last notation is the row number where you write it down. So -1 plus 1, 1 plus -1 is 0. -2 plus 3, add them gives me 1. 3 plus 0 is 3. 9 minus 4 is 5. Perfect. So now, I'm still not done with step 2. I want a 0 underneath. So therefore, I want this to be a 0. I'm going to use the 1 above to make that a 0. So what should I do? Well, I need to just change the last row. So that means that my first row and my second row will stay the same. The only thing that's going to change is my third row. So how can I make that 0? I need to multiply this by -2 and add it to row 3. So I'll multiply row 1 by -2, and I'm going to add it to row 3. So it gives me, notice that whenever I multiply, I prefer to place the -2 in here, so it kind of helps me make less mistakes. That gives me -2 times 1 is -2, plus 2 is 0. So this is the one that I'm changing. -2 times -2 is +4, minus 5 is -1. -2 times 3 is -6, plus 5 is -1. -2 times 9 is -18, plus 17 is -1. And let me place my line for my equal sign. So I finished with step number 1. I finished with step number 2. Step number 3 is to make this a 1, which is already 1, and sometimes that will happen. Step number 4, I want to make the number underneath a 0. So I'm going to use this one, use the one on the second column to make that a 0. So therefore, my third row is the only one that's going to change. My first row stays the same. My second row stays the same. My third row will be the one that changes. So therefore, what do I need to do to row 1 and add it to make that 0? I just need to add it. So it'll be row 2 plus row 3. I'm going to add 0 plus 0 is 0. 1 minus 1 is 0. Gives me 2 and gives me 4. So therefore, we finish step number 4. The last step is to make this a 1. On the last step is the only step that you should be multiplying. There are always exceptions, but try to not do it unless you have to, because otherwise you end up with lots of fractions in the way or in the process. So therefore, my last row is the only one that's going to be modified. My first row stays exactly the same. And I'm going to multiply by 1/2. I'm going to take half of row 3. So it gives me 0. This is the only one that I'm changing. So half of 0 is 0, half of 0 is 0, half of 2 is 1, half of 4 is 2. And I usually do write it down in here. So just everything by half. Now that I have it in this form, I have it in row echelon form, where I have my zeros on my triangle underneath. Now I can rewrite it back as a system of equations with x, y's, and z's. So this is x minus 2y plus 3z is equal to 9. There's no x, but there is a y, plus 3z is equal to 5. There's no x, there's no y, but we do have a z is equal to 2. And now we can solve it. So we know z is equal to 2. So therefore, I need to be able to find y next. And just the same thing that we did last time. Now it becomes an easier problem. And we have y plus 3z is equal to 5. I'm going to place that 2. So y plus 6 equal to 5. Y is equal to -1. And now that I have the y value, I can find the x. And I'm going to plug into the first equation. So it'll be x minus 2y plus 3z is equal to 9. Y is -1. Z is 2. So x plus 2 plus 6 equal to 9. X plus 8 equal to 9. X is equal to 1. So therefore, my solution is a point. In this case, your x value is 1, your y value is -1, and your z is 2. And if I want to double check, I can plug in back into the original equations into each one of them. Or I can use GeoGebra to be able to find the intersection. Example number 4. You should have a cutout. Go ahead and glue it. And write down example number 4. Once you guys are ready, we can continue. Go ahead and pause it. Excellent. So in this case, this is called reduced row echelon form. And notice that's going to be very similar. Every leading number has to be a 1 once again. But the biggest difference is that now we're going to have zeros underneath and zeros above. So below and above on each one. So notice that on the second one, we have 1, there's 0 here, but even that meets the same requirement. 0 below and 0 above. There's no 1 in here, so it doesn't matter. In this case, but I still want a 0 here and a 0 above if you can. And on the last one, you have zeros underneath and zeros above. You can have a 5 here because there's no 1 below it. And to be able to rewrite in this form, first we're going to rewrite it in row echelon form, and then there's 2 additional steps. So if you can write this equation, this system in augmented matrix, so let's go and do so. We have a 2, a 1, and a 5, negative 3. 1, 2, 8, negative 5, negative 1. There's no y, so it'll be 0, negative 2, and 1. And now our first task will be to rewrite in row echelon form first, using the steps. Step 1, I want to get a 1 here. Different ways of doing it. There's not an incorrect way, but in this case, what should I do? Talk to your neighbor, and then we can decide. What should be the first step? Correct. So you can add, but in this case, there's a 1 here, so I'm just going to switch my row 2 and my row 1, which means that the only row that will stay the same is row 3. So we have negative 1, 0, negative 2, and 1. So the only one that will stay the same was row 3. We switch those 2 around, and now we have a 1, just like we now have 2, but I do need to make a notation that I did switch those 2. Second step is to make the ones below the 1 is 0. And I'm going to use this one to make those a 0. Not necessarily, but it's a good idea to just as a beginning to just kind of follow the rules. So therefore, I want to make this 2 a 0. So the only one that I'm going to change is row 2. You can do more than one step, but just be careful. For now, we're going to keep it simple. The first row stays the same. The last row will stay exactly the same. That means the only one that's changing is row 2, which means that your notation should be on the left of row 2. I do need to see the notation when you guys are working on your homework. So how can I make this a 0? I'm going to multiply this by negative 2 and add it to row 2. So we're going to multiply by negative 2 and add it to row 2. So multiply row 1 by negative 2 and add it to row 2. And when I multiply, I should place it on the left. So negative 2 plus 2 is 0. Negative 4 plus 1 is negative 3. Negative 16 plus 5 is negative 11. Positive 10 minus 3 is 7. One small mistake will throw the whole work out of whack, and you have to redo it, so just be careful. Next, I'm going to use this 1 to make, I'm still on step number 2, to make this a 0. So how can I do that? That means I'm only going to change row 3, which means that row 1 will stay exactly the same. Row 3 is the one that's going to change. So how can I achieve that? That means I'm going to add row 1 to row 3. Row 1 will get added to row 3. So 1 minus 1 is 0, 2, 6, negative 4. So I finished with step number 2. Step number 3, I want to make this a 0. Okay, 1 in the second row, second position. And I'm going to use row 3. So what can I multiply the 2? So whenever I add to the negative 3, it gives me a 1 by 2. Now notice that in this case, we are going to only change row 2, which means that row 1 will stay exactly the same. Row 2 will stay exactly the same. And we are only changing row 2. So your notation should be on row 2. So what do I need to multiply the 2? I need to multiply by negative 2, R3, and I'm going to add it to R2. And I prefer to place a negative 2 in here. It makes it a little easier for me to see the process. 0 plus 0 is 0. And I need to multiply by positive 2, right? Not by negative 2. Because otherwise I need it to be 4 minus 3 gives me a 1. 12 minus 11 gives me a 1. Negative 8 plus 7 is negative 1. Now that I finished step 3, I'm going to go to step 4. And step 4 tells me that I need to make this a 0. So use the 1 above to make that a 0. And I'm going to continue to the right. So way above it. Let me zoom out. So therefore, what can I do to 1? So whenever I add it to 2, it gives me a 0. I'm only going to change row 3. So let me just keep 1 the same. The second one will stay the same. And I'm going to change row 3. So what should I do? I want this to be 0, so I'm going to multiply this by negative 2 and add it to row 3. So I'm going to multiply negative 2, R2, and add it to R3. And that is the proper notation. So therefore, multiply by negative 2. Notice I place a negative 2 in here, helps me. Negative 2 times 0 is 0, plus 0 is 0. Negative 4. That should be on row 2. Let me try once again. Negative 2 times 0 is 0, add 0. Negative 2 plus 2 is 0. Negative 2 plus 6 is 4. Positive 2 minus 4 is negative 2. And now I'm down to the last step, where I want this to be a 1 as well. In the last step, I can multiply by a number. So I'm going to multiply by 1/4. So it means that the first equation row stays the same. The last row is going to change. And I'm going to multiply by row 3 by 1/4. And I'm right here, so it makes it a little easier. So it gives me 0, 0, 1. 1/4 times negative 2 is negative 1/2. Now, if it was the previous problem, it will be done. But now we have a few extra steps. Now that we are here, I want to make that a 0. I'm going to use the 1 in the middle to make that a 0. So therefore, we're going to change only row 1, which means that row 2 will stay the same. Row 3 will stay the same. And I'm going to change row 1. So therefore, what do I need to multiply 1 to make it into a 2? So I can make this a 0. So this multiplied by -2 to make that 0. So I'm going to multiply -2, row 2, plus row 1. And I'll place a -2 right next to it so I remember what to multiply. 0. -2 plus 2 is 0. That's what we want. -2 plus 8 is 6. -2, positive 2, -3. Next, I want to use this 1 to make the numbers above a 0. That's the last step. Let's go and make that 6 a 0 first, or the 1. It really doesn't matter since we're going to use this for both. Let's make that a 0. That means that the last two, the first one is going to change, which means that the second one and the third one will stay the same. So what do I need to multiply the 1? So whenever I add it with a 6 gives me a 0, will be -6. -6 are 3, and it needs to be on the first row, since that's the one I'm changing. -6 are 3 plus R1. And I'm going to multiply this by -6. 0, 0, -6, 0, positive 3, and it happens to be 0 as well. The last step, I want to make that is 0. So what do I need to multiply out? See what you get for the last step, and we can compare answers. Go and pause it. Excellent. So in this case, again, I'm going to switch in the second row. And where did I make a mistake? This should be a 1. Did you guys catch that? That should be a 1. That's because whenever I multiply by -2 times 0 is 0, plus 1 is 1. Second row is going to change. The third row will stay the same. And I just need to change the second row. So what do I need to multiply? By -1. So be -R3, -R3 plus R2. Remember, this has to match. -1 times 0 is 0, plus 0 is 0, 1, 0. Positive 1/2 plus -1 is -1/2. So now that I have this, now we have our solutions. We can rewrite it. This is your x, no y, no z, so therefore x equal to 0. This is your y is equal to -1/2, and this is your z is equal to -1/2. So we have our solutions. X is 0, y is -1/2, z is -1/2. And I can check by two ways, by graphing it or by plugging it back in. But for now, let's move on to the last example. Go and copy it down, then rewrite it as a augmented matrix, and go through the steps and see what you get. And then we can compare our answers afterwards. This is going to be a little interesting, so once you have it in this form, stop, and then we can check. Excellent. So now I'm going to place it as an augmented matrix. So it gives me 1, 1, 5, negative 3, 1, 2, 8, negative 5, negative 1, 0, negative 2, 1. And now, first, I need to have that 1. That one's already 1. So now I'm going to take this 1 and make those 2 zeros. So actually, I can just take this negative 1 and add it. So I'm going to do that instead. I'm going to change row 2. Row 1 will stay the same. Row 2 will change. And I'm going to take row 3 and add it to row 2. So I'm going to take row 3, add it to row 2. Notice that notations are 2. So that's the one that's going to change. So it gives me 0, gives me 2, gives me 6, and gives me negative 4. Now I'm going to make that a 0 by adding row 1 to row 3, which means that the first row will stay the same and the second row will stay the same. The third row is the one that's going to change. So therefore, I'm going to take R1 and add it to R3. 1 minus 1 is 0. That gives me 1. That gives me 3. And that gives me negative 2. Next, I want to make this a 1. So let me just switch them around. The notation will be on the next step. So let me just not write anything. So therefore, there'll be 1, 1, 5, negative 3, 0, 1, 3, negative 2, 0, 2, 6, negative 4. So I switch those two around. That way I have a 1 in here. And I'm going to take this 1 and I'm going to make that a 0. So I'll multiply by negative 2 and add it to the one below. So therefore, my first one is not going to change. My second one is not going to change. My third one is going to change. That's it too. Just be careful. One minor mistake will throw the whole thing off. So therefore, I'm going to change this one. I need a notation right next to it. So I'm going to take R2, negative 2, R2, add it to R3. Zero plus 0 is 0. Negative 2 plus 2 is 0. Negative 6 plus 6 is 0. And that gives me positive 0 as well. Now, when this happens, that means that you have 0 equal to 0. All your x's, your y's, and your z's got canceled, which means that this is a true statement. That means that you have an infinite number of solutions. And now we need to be able to find the solutions. Sorry for my messy writing, but I had to rush through this. X plus y plus 5z is equal to negative 3. We have y plus 3z is equal to negative 2. Now we have an infinite number of solutions, so we do have solutions that we need to find. What do you guys want to solve, for y or for z? We're going to solve for y, so it means that y is equal to negative 3z minus 2. Now if I wanted to, I could have actually just gone back and placed this as a 0 as well. But for now, we're just going to do it as this. My solution, x, y, and z, where you have your y to be negative 3z minus 2. That's your z, so therefore this is your z. So I just need to find my x. So we have x plus y, we know that the value of y is negative 3z minus 2 plus 5z is equal to negative 3. And now we can solve it. So we have x plus 2z equal to negative 1. So x equal to negative 2z minus 1. And that is my solution set. And from there I can find additional solutions by plugging a 0, a 1, and a 2. But for today, that's our lesson. Homework will be posted online.